Good afternoon, students. Am I audible?
Yes, sir.
Oh, just give me 2 minutes time, okay? I'm just getting my notes. Till that, keep revising the topics that we have discussed till now. So we'll get started, guys. So I've got a simplified version of certain notes, okay, from where I'll be explaining things. So I hope you're able to see, right?
Yes, sir.
Very good. So till now we have discussed about all the optical devices that were having different kinds of functionalities in terms of reflection and refraction. Now, the next concept that we are going to discuss is about the optical instruments. So basically, what does an optical instrument do? So if you look at the name of the chapter itself, it is ray optics and optical instruments, right? So basically, we'll understand what an optical instrument is. Optical is something which refers to, right? Instrument is a device which is basically which is constructed by suitable combination of certain objects like mirrors, prisms, and lenses, so that it assists the eye in viewing an object. So what is the meaning of this statement? Can someone tell me what is the meaning of this statement? So what do we mean by assisting the eye in viewing an object? What is the meaning of this? So basically, they're trying to say whichever object you're not able to see with a naked eye. That is, like, let's say somebody has a defect with eye. So what are they supposed to do? They are not able to see far objects. So what are they supposed to do? They need to take the help of an optical instrument called spectacles, right? So they need to wear the spectacles to understand or to see the objects that they're not able to see with the naked eye. The same thing happens. So it assists the eye in viewing an object, right? So if you look at the principle of working of an optical instrument, it is basically based on the laws of reflection and refraction of light. So if you talk about the common types of optical instrument, one is the projection instrument, right? So you know what is a projection instrument? It is basically a projector. The one which we use in our schools and everything, where they connect it to the laptop and things will be projected onto the screen, right? So that is one such instrument. Next is, you talk about microscope. So you talk about microscopes. So what are microscopes? They are also used to see very small objects in a magnified form, which otherwise cannot be seen distinctly when placed close to the naked eye. You know what are all the types of microscopes that exist, right? One is a simple, and the next one is a compound microscope, right? So compound microscope is the one that is used in biology lab to see microorganisms. Similarly, the next type of the optical instrument that we can speak about is the telescope. So we are going to see about the individual optical instruments except projector. So the three instruments that we'll be concentrating in our syllabus is simple microscope, compound microscope, and a telescope. Am I clear till this point? So why are telescopes used? So telescopes are mainly used to see the astronomical and distant objects in a magnified form, right? So which you cannot see obviously with the naked eyes, right? Is it clear till this point? It's a simple thing, right? It's a basic introduction of all these points.
Yes,
right?
sir.
Right. Now you see the important concepts that we need to know before we proceed with the concepts of simple and compound microscope and telescope is you need to know certain technical terminologies which are associated with them. So one is called as the visual angle. So what is visual angle? If you look at the size of an object as perceived by the eye depends upon the size of the image formed at the retina. Accepted? Right. If I look at this diagram, if I keep the size of the object here, the image is formed near the retina. Right. So the size of the image formed at the retina is roughly proportional to the angle subtended by the object at the eye, and that angle is what is called as the visual angle. Guys, are you able to see what is given here? Just give me a minute. Now I'll shift it to some other software. The software is slightly difficult for me to write. Yeah, I got it. Yeah, see. So try to understand this. If I place an object here, right? If I place an object here, then from the top of the object, there is a ray that is going. And from the bottom of the object, there is a ray that is going. So if you observe, this whole thing is going to be the size of the image perceived by retina, right? By our eye at retina. Similarly, if I take an object and place it at a far distance, you're able to see that it is going and falling at this part, and one more ray is going like this. So if you see, this is the size of the other image that is formed by the retina for the other object, right? So you're able to see that there is an angle that is involved. So this thing is going and forming like this, right? If this is the object, so this is going to be the size. Are you able to see some angle that is being subtended? You need to understand this point, right? So the size of the image that is formed is completely dependent on, I can say that this angle. So this angle is where it is closer to the eye, right? So when the object lies to the, so that object, the angle that they are trying to talk about is what is called as the visual angle. When the object lies close to the eye, its visual angle is large, and hence the image I1 formed at the retina is also large. Whereas when the object is taken far away from the eye, its visual angle becomes small, and hence the image I2 formed at the retina is also small. So you're able to understand this point. So theta1 is the visual angle subtended at the eye for near position of the object, and theta2 is the visual angle subtended at the eye for the far position of the object. Since theta1 is greater than theta2, we can say I1 is greater than I2. Have this point in your mind. Okay. Now, we need to answer an important question. Why is a microscope needed in the first place? So why do we use a microscope? To see enlarged images, right? So we use them to see the enlarged images. Correct?
Yes, sir.
So optical instruments are basically used for increasing the visual angle artificially. So what is that you're able to understand? More is the visual angle. So this point you're clear that if more is the visual angle, more is going to be the size of the image. So more is going to be the size of the image, more is the detail that you can see with respect to that image. Like for example, if I'm able to zoom in, you're able to see things better compared to the zoom out position, right? So for having better details, what we are going to do is we are going to increase the visual angle of that particular object, which is formed at the retina using some artificial method. And that artificial method is what is done by these optical instruments. Okay. So for that, there is something called as magnifying power or angular magnification. I told you in the beginning of the chapter itself. When you talk about magnification, what comes to your mind? Can you define magnification? It is a ratio of something. It is the ratio of size of image to
the size of object.
right. This is what we call it as magnification. But I need to do a small correction in my definition, in my term, not in the definition. Definition is right. But what should be the prefix that I need to add with respect to this magnification for me to define something like this? I need to add a word called as linear magnification. So linear magnification is the size of the image to the size of the object. Whereas when you talk about the optical instruments, it involves angles, right? So since angles are getting involved in the case of optical instruments, we speak about a parameter called as magnifying power, which also has another name called as magnification only. Magnifying power is magnification only. But what is the prefix added to it? It is the angular magnification. Okay. So from this, what we can conclude is magnifying power or angular magnification M is the factor. Okay, factor means it's a multiplication factor by which an image formed on the retina can be enlarged by using a microscope or a telescope. So this is the concept of magnification we are going to use for any kind of an optical instrument. So having this in mind, what we can say is, if you take a microscope, right? So if you take a microscope, please write it down. The definition of magnifying power is something like this. It is a ratio of the visual angle subtended or formed by the final image at the eye to the visual angle subtended by the object at the eye. So write it down. I'll explain when I explain for the different kinds of instruments. So please write it down. How do you define magnifying power of a microscope? It is defined as the visual angle subtended by the final image at the eye to the visual angle subtended by the object at the eye when object is kept at distance of distinct vision. I'll come to that point. Is it clear till this step?
Yes, sir.
Right. Now, obviously, it is not going to have any units. Going to the next part, if you take the telescope, then how is the magnifying power defined? It is also defined as a magnifying. It is also defined as the ratio of the visual angle subtended by the final image at the eye to the visual angle subtended by the object at the eye. But in this case, when you see it from the naked eye, you are not going to keep the object at least distance of distinct vision. Here, if you observe, both the definitions are same mathematically when you write it. But if you look at the denominator, here the visual angle subtended by the object at the eye when kept at capital D. This capital D is what is called as distance of distinct vision. Distance of distinct vision. So any idea about what we are trying to talk about? What is the distance of distinct vision? Any idea about what is the statement? It is also called as least distance. Any idea about what is this least distance of distinct vision? So, yes or no, guys?
No, sir.
Okay. So write it down. Least distance of distinct vision, or you can call it as near point. So this is generally 25 centimeter for a normal human eye, which does not require any optical instrument to support. Means you have your eye here, right? If I keep an object here, right? If you keep an object very close to your eye, what will happen? Let's say you have a pen, you take a pen and keep it almost close to your eye. Will you be able to see the pen, the whole pen comfortably?
No, sir.
Right. So if you have to see it comfortably, what are you supposed to do? You need to move this pen to a certain distance so that your eye is able to see the top as well as the bottom without any strain in it. So that distance, the minimum distance from the eye where you're able to see an object without any strain in your eyes is what is called as least distance of distinct vision, and basically it is taken to be 25 centimeters. Okay. Sometimes if there is a defect, if it is a defective eye, then it will be somewhat less or more, depending on what kind of sightedness they have, what kind of a defect they have. Am I clear with this? This is what is called as least distance of distinct vision, or the other name for it is near point.
Yes, sir.
Right. So have this in your mind. Let me see if I'm able to write this. Software issue. Just give me a minute, please. issue is up. Listen. Now see. So having all these points in mind, first we need to understand how a simple microscope works. So simple microscope is basically a simple convex lens, right? So what is the work of a microscope? So microscope basically magnifies the size of an object, right? So when it has to magnify something, um, I have to say that the image size is greater than the object size. That is when we can say it is magnified image. So having this point in mind, and secondly, all these devices, the microscope or telescope, will always form virtual image. What do they form? They form virtual image. Have this point in your mind. Now, having said this, when we talk about a simple microscope, it is also called as a magnifying glass. We have two kinds of lenses in our hands. One is a convex lens and one is a convex and concave lens. Right. So when this is going to be the scenario, tell me, will concave lens, the first lens that I've drawn here, will concave lens form a real image or a virtual image? Will concave lens form a real image or a virtual image?
Virtual.
It is always going to form a virtual image. But the question is, since it is forming a virtual image, which is the basic requirement of an optical instrument, can this be used for magnifying? Can this be used for magnification? The answer is no, because concave lens will always form a virtual image which is diminished. Whereas when you talk about a convex lens can form real and virtual images. So where will it form real images? When you place the object till focus. So between infinity to focus, if you place the object anywhere, it will always form a real image. Whereas when is it going to form a virtual image? When you place the object between the focus and the pole. So when you place it, it will form a virtual image which is magnified. So having this point in mind, what we can say is, if you take a convex lens of a short focal length, right, then that can be used to see magnified image of small object and is called magnifying glass or a simple microscope. Okay, so we know the fact that when a small object is placed between the optical center and the focus of convex lens, it forms a virtual erect and magnified image on the same side as that of the lens. This is a known fact, right? So generally what they do is, this lens will be held close to an eye and the distance of the object is adjusted till the image is formed at the least distance of distinct vision. So what they are trying to say is, we are going to calculate the magnifying power of a simple microscope. So what is the magnifying power of a microscope? It is a visual angle subtended by whom? By the final image at the eye to the visual angle subtended by the object at the eye when it is kept at the least distance of distinct vision. So having said this, what we can do is, first, let us say I have an object. Okay. So I have an object where I look at this object. So I need to ensure the distance between the eye and the object is adjusted in such a way that I am able to see the top and bottom of this object. And let's say this is the visual angle theta with a knot. So theta naught, that is subtended by the image at the naked eye. Okay. Then how much is this distance going to be? It is d. Then how much is this? This is the height of the object, right? Now what I want to do is, height of the object, let's say you're looking at a pencil which is 5 centimeter. Now you want to put a microscope in between your eye and this object so that the image is formed on the same side as that of the object, but this time it should be magnified. Okay. So this time it has to be magnified, means you will put the microscope like this, where this is the initial position of the object. But what will happen is now the eye will no more be able to see this object. Rather, it will see that this as the object, which is actually the image formed due to this convex lens. Tell me one thing, are you able to understand this ray diagram? So I'll tell you how to draw this ray diagram. Observe, it is very simple. Guys, are you able to hear me?
Yes, sir.
Okay. I see that there was a screen share that got cut off. So I was continuous, right? My voice didn't break and all those things.
Yes, sir.
Okay. Now, the question is, are you able to see how this diagram is drawn? So if I place an object here, right? So you take a ray parallel to the principal axis. Where is the object placed? It is placed between the focus and the optical center. So when you take a ray parallel to the principal axis, what will happen is, the ray will pass through the focus on the other side. When you take the ray through the optical center, what is going to happen? It will pass without any deviation. Now, what will happen is this ray and this ray, they will get diverged away from each other in such a way that the final image is formed virtually like this. If I backtrace both these rays, they virtually tend to meet at this point, and this is what your eye will be able to see now. But actually, if you observe, the height of the object is only h, but the height that is perceived by the eye will be hi. It will be something greater. Now it is able to see a magnified image. Okay. Now what should happen is you should adjust this lens between the eye and the object in such a way that the final image of this object is formed at which point? Is formed at the least distance of distinct vision. So here I would like to stress on one point. The thing that will confuse you is, here also I have least distance of distinct vision. Here also I have least distance of distinct vision. So the difference is, here first what you're trying to do is, you're trying to find what is the angle subtended by this object at the naked eye when there is no optical instrument present. So for that scenario, you are adjusting the distance between the eye and the object in such a way that the object is kept at least distance of distinct vision. So this doesn't mean that the object distance with respect to lens is also least distance of distinct vision. Don't get confused. The object distance between the lens and the object distance is u, okay, and the focal length of this lens is f. So you definitely need to keep the object between the focus and the center of and the optical center. But what is the adjustment you need to do? You need to adjust the position of the microscope with respect to eye in such a way that the final image, the enlarged image is there, right? That enlarged image should be ensured that it is formed at the least distance of distinct vision. Are you able to understand the difference?
Yes, sir.
Am I clear with these two? Right. Now I have a question to be answered. My job is to define magnifying power. I need to define what is magnifying power. So what is magnifying power of a microscope? Tell us. It is the angle subtended by whom the final image at which point near the eye divided by the angle subtended by object at. So when this is the scenario, when you're trying to calculate the magnifying power, remember one thing with respect to simple microscope, compound microscope, and telescope, you will have two cases. One of the cases, the adjustment of the lens is done in such a way that the final image is formed at least distance of distinct vision. And the second case is where the image is formed at infinity. So the adjustment should be done in such a way that the image is formed at infinity. And this is also called as relaxed viewing. Okay. or more technically it is called as far point adjustment. I'll come to that point. So now we are discussing about the final image formed at the least distance of distinction. So assuming that things are clear, I need to explain about the angles. Listen to this carefully. Listen to this carefully. This is where the confusion will start. Now, if I take this as the height of the object, right? So draw a line along the principal axis, and from the top, draw a line towards the eye. When you draw it, these two lines will meet at a point, and you can see that there is an angle subtended by it. Right? You're able to see an angle subtended by it, which if I backtrace it here, so it is this angle. See, if I take this as the height of the image, from here, if I draw a line, and here, if I draw a line, these two are meeting. And what is the angle subtended by it? What is there inside? You're able to see, no? Sorry, the
Beta.
image quality. Yes, this angle is beta. Now tell me, magnifying power requires two angles, right? Angle subtended by the final image and angle subtended by the object at D. Now beta is which angle? Is it the numerator one or the denominator one?
Numerator.
It is a numerator. Very good. So it is beta. So it is here, but you have to think and tell me. So it is the one which is formed in the numerator. Now see, what is alpha then? Alpha is the angle subtended by the object when it is kept at least distance of distinction. So if I take the projection of object, what am I doing? I'm taking the projection of object onto the image, then this will be the height that is subtended by the object on the image. So this is the share of height taken by the object from the image. So from here, if I draw an angle, and if I draw a line like this, then what is this angle? This angle is what is alpha. So beta divided by alpha is what is going to give us the magnifying power. Am I clear with this?
Yes, sir.
Right. So this is the first important definition you need to understand. Now comes an important point. Remember, the angles that are subtended here are going to be very, very small. So when they are small, we keep doing an approximation. What is that? You can approximate the angle to either tan or you can take it to sine. Okay. So therefore, the angles of alpha and beta can be replaced with their tangents. So can I say that the magnifying power in this scenario is going to be tan beta divided by tan alpha? Right. So having said that, now see, whenever I need tan of an angle, what will you do? You'll take vertical divided by horizontal. So if I take tan of alpha, if I take tan of alpha, right? So what is tan of alpha? It is the height of the object to the least distance of distinction. Is it not h divided by d?
Yes, sir.
Right. So tan alpha is equal to h divided by capital D. Then what about tan beta? Tan beta, if you take it, you look at it and tell me, it is going to be h dash divided by D.
D.
Right. So tan beta will be equal to h dash divided by D. So what is going to be the magnifying power? It is tan beta divided by tan alpha. Remember, this magnifying power is angular magnification. So tan beta, I will write it as h dash divided by d, and tan alpha, I will write it as h divided by d. D and d will get cancelled. So what is that you're left out with? H dash divided by h. Actually, what is the derivation with which we started? We started with angular magnification. But what is h dash? H dash is the size of the image to the size of the object. So what does it mean? Mathematically, in the case of a simple microscope, can I say that the angular magnification is exactly equal to the linear magnification? Yes. Think about
Yes,
it.
sir.
Right. when this is going to be the scenario, then what is going to be the value of magnification? So MD will be equal to H dash divided by H. And we know this fact, 1 by V plus 1 by U is equal to 1 by F. It's the lens formula. So 1 divided by, where is the final image formed in this case? In this scenario, where is the final image formed? It is at the least distance of distinction 1 divided by minus D plus 1 divided by, where is the object placed? It is at minus U is equal to 1 divided by. We know that the focal length of a convex lens is positive, right? So 1 by D plus 1 by minus U is equal to 1 divided by F. Okay, so H dash by H. What is a formula for linear magnification of a convex lens or a linear magnification of a lens in terms of V and U?
V by U.
Yes. So it is going to be V divided by U. So in this case, what is V? It is the least distance of distinction divided by U. Okay. So having this in mind, observe. I will multiply with D on both sides. If I multiply with D on both the sides, I'll get minus 1 plus D divided by U is equal to D by F. Right. So D divided by U, can I write it as 1 plus D by F? But what is D by U, guys? It is the angular magnification. So angular magnification in the case of a simple microscope will be 1 plus D divided by F. Okay. So this is the derivation for the angular magnification of a simple microscope. So I want you all to make a note of it. While noting it down, if there is any doubt, get it clarified. If any of the points is not clear, please get it clarified.
Sir, I have a doubt, sir.
Tell me. Yeah.
It should be minus 1 minus V by U, right, sir?
Minus 1. Yeah. By V plus 1 by U is 1 by F. I made a mistake, sorry. Lens formula is 1 by V minus 1 by U. I wrote the mirror formula. Now it makes sense. Now multiplying with D on both the sides, minus 1 plus D by U is equal to D divided by F, which implies D by U is equal to 1 plus D. So magnifying power is equal to, Rohan, now is it fine?
Yes, sir, no sense.
So this was a mistake. I wrote mirror formula instead of lens formula. So let me know if it is done.
Done, sir.
So this is the magnification of a simple magnification produced by a simple microscope when the object is formed at least distance of distinct vision. Now what we will do is we will do the adjustment in such a way that we will make the image get formed at infinity. So if the image has to get formed at infinity, where should the object be placed? Hmm? If the image should be formed at infinity, where should the object be placed? Okay, let me put the question like this. If the object is placed at infinity, where is the image formed?
Focus.
Focus. So do the reverse. If the object is placed at infinity, image is formed at focus. Use the reversibility of light. If the object is placed at focus, the image is formed at infinity. That's it. So what we need to do is the smallest difference that exists here is you need to adjust the distance in such a way that this object which is actually present is no more between the focus and the center of optical center. Rather, this exactly be at the focus itself. So when it is formed at the focus, then what is going to happen is then the image is formed over here. Image is formed at infinity. So from image, if I draw a line and bottom, I draw a line like this, then this angle is going to be the angle subtended by the image beta. Now for the angle subtended by the object, what you're supposed to do is from the object project it to the least distance of distinct vision, because initially before placing the convex lens, where are you seeing the object at? You're seeing at least distance of distinct vision, right? When that is going to be the case, then the angle subtended by the eye at the center, the angle subtended by the object is going to be alpha. Again, what is magnifying power? So magnifying power this time is not going to be MD, it is going to be M infinity, right? M infinity is still the same. Tan beta divided by tan alpha, right? But the question is, what is tan beta from this triangle? What is tan beta from this triangle? This is H. So tan beta is H divided by F
Yes, sir.
divided by, what is tan alpha? H divided by D. Cancel it, you will get D divided by F, right? So the magnifying power of the same simple microscope, when you do the adjustment to the relaxed viewing or far point, then the magnification is going to be D divided by F. Right? So this is the derivation, only these many steps, but you need to understand the concept behind it. So what is the difference? In the previous case, it was 1 plus D by F. In this case, it is only D divided by F. So you should know which formula to use under which scenario. Right. So I'm assuming that these are over. Right, D divided by F. So you can observe that the magnifying power of the simple microscope is one less when the image is formed at infinity. But what will happen is the viewing of image will be more comfortable because the image is formed at a greater distance. So your eyes will be little relaxed to see that. Okay. So these things, you can read it on your own. who uses all these glasses, right? So shall we try this problem? So there is a man
Yes, sir.
with normal near point. What is normal near point? It is 25 centimeter. Not near point means least distance of distinction. Okay. So what is he doing? He reads a book with small print using a magnifying glass. Okay. Of focal length 5 centimeter. Find the closest and the farthest distance at which he can read the book, right? When viewing through the magnifying glass. So when he is reading through the magnifying glass, the image is formed on the other side, right? His eye will be on this side, magnifying glass is here, and the final image is formed here. So the closest distance at which he can read the book when view. So find the closest and the farthest distance at which he can read the book when viewing through the magnifying glass. So what are the closest distance at which he can see the image? So when he is reading, he needs to read it comfortably. So the least distance that is possible is minus 25 centimeter. Because always remember, with respect to ray optics, the object should be kept on the left hand side. So if I take this as the convex lens, then what will happen is the height of the image is formed here. Okay, this is height of the object, this height of the image, this is D. So the minimum distance at which he can read the book clearly is minus 25 centimeter, and he can adjust it to read it more comfortably by taking it to minus infinity. Okay, this is a theoretical question. So having said this, the next part of the question is formed. So what is the next part of the question? It says maximum and minimum magnifying power possible by using the above simple microscope. So when can you get maximum magnifying power? Hmm? So when can you get the maximum magnifying power? So you have two values, Noda. 1 plus d by f and d by f. Which one is more?
1 plus b by f.
So for you to get maximum magnifying power, where should the image be formed? It should be formed at minus 20. Minus 25, calculate it. So calculate the magnifying power as 1 plus d by f. Calculate the magnifying power as d by f. So 1 plus d by f is 1 minus 25 divided by the focal length of this is plus 5. So how much is it going to be? 1 minus 5 minus 4. And this will be how much? Minus minus 25 divided by 5. This is a convex method. But magnifying power should come as positive value. One minute. 1 plus d by f, 1 minus 25 divided by 5. Oh, sorry. In this case, we have derived this formula for a particular case, right? So I'm sorry, in this case, we have derived it for a particular case. So what we will do is 1 plus d, you will not put it as minus 25 because you have already done it in the derivation. And there is only one such scenario for which this formula is applicable, right? So 1 plus, this is going to be 25 divided by 5. So this will give you 6. Whereas m infinity is going to be 5. So which is a maximum magnifying power? Maximum magnifying power is 6 and the minimum magnifying power is 5. Is it clear, guys?
Yes, sir.
So this is all about a simple microscope. So just to summarize, can you tell me what are all the steps you need to remember? So how are you supposed to prepare? So first you need to know what is visual angle. Let's just summarize whatever we saw today. So you need to know what is visual angle. Once you know visual angle, you need to know what is magnifying power. So magnifying power is ratio of angle, the visual angle subtended at subtended by image, by the angle subtended by object, right? So having this in mind, subtended by the object at least distance of distinction. So by default, you should always look at the object at the least distance of distinction with naked eye, and that angle will be alpha. So height of the object and least distance of distinction. In the second scenario, what will happen? You will have a convex lens. So in the convex lens, you will place the object between the focus and the optical center. So where will the image be formed? The adjustment should be done in such a way that the image is formed at the least distance of distinction, right? So if you take something like this, then this angle is going to be beta. Then what are we supposed to do? Magnifying power should be taken as tan beta by tan alpha. But tan beta by tan alpha on solving, you will get it as h dash by h, which is also equal to v divided by u. Then you will apply lens formula and derive the magnifying power at d as 1 plus d by f. Similarly, if the object is placed at focus, okay, then the image is formed at infinity, and this angle will be beta, and this angle still holds out to be alpha. So magnifying power at infinity will be equal to h divided by f divided by h divided by d. H and h will get cancelled, so d divided by f, right? So what is the other name for the case of image formed at infinity? It's called as far viewing point or comfortable view, right? So this basic is very important for you to understand how the next optical instrument, that is a compound microscope, works. Okay, so if you see, compound microscope will use two lenses. One is called as objective and the second is called as eyepiece. Okay, so for you to understand this concept, you need to first master the simple microscope. So if you guys take time to revise the concept today and practice the derivation again, in the next class, I will explain compound microscope and we can finish telescope also. Okay, because enough basics have been created. Right? So any other doubt from today's class?
Sir, can you share this PDF, sir?
Yeah, I'll do it.
Okay. Thank you, sir.
That's it. So just a minute, guys. Don't leave, just a minute. Yeah. Now you can check your group. I've shared the PDF in WhatsApp. So you can read it before tomorrow's class. Okay.
Thank you, sir.
So that's it.
Thank
Okay,
you,
I'll see you
sir.
guys tomorrow.
Thank you.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.